In section 10.2, you're going to start learning how powers work and what their properties are. So while each of these may seem easy, when you start putting all these together, this may be challenging for some of you, and that's okay. You will get through it. But I want you to have a clear understanding of what each of these powers say. So today, what we're going to do is we're going to develop two rules ourselves. So I want you in your notes to draw a line down the center of your paper. And I want you first to write on the left side, this is going to be rule number 1, and on the right is rule number 2. So on the left side, I want you to write x to the third power times x to the fifth power. And I want you to make a guess of what you think that is. What do you think x to the third times x to the fifth power is? Do you think it's x to the 15th? Do you think it's 15x? Do you think it's x to the 8th? Well, if we take what we learned in 10.1, 10.1 talks about what exponents mean. And we should know that x to the third stands for x times x times x. The x to the fifth stands for x times x times x times x times x. That is, x times itself 5 times. If we put this all together, though, how many x's are there? So you can rewrite it as x to the 8th power. So what can you tell me about the powers and then getting an answer of x to the 8th? We added them. So the next thing, let's look at x to the third to the 5th. X to the third to the 5th. Now, how many x to the thirds do you have? You have 5 of them. So this would be x to the third times 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 x to the third. Now, if you wanted to, you could take each of these x to the thirds and break them down into the 3 parts. So you could have 5 parts of 3. Now, go back to rule number 1. What did we say to do with these powers? We added them. So what do you think you're going to do with all these powers? You're going to add them. So that gives you x to the 15th. So how do you go from this to this? X to the third to the 5th to the 15th. We multiply. So that's your second rule. So let's go over our key ideas. All right, our first property says this. To multiply powers with the same base, add their exponents. So here's how it looks. In using numbers, we would say 4 to the second power times 4 to the third power equals 4 to the 2 plus 3, which gives me 4 to the 5th power. Now, if we write that as algebra, in algebra we could say this. A to the m times a to the n equals a to the m plus n, because we can add the powers together. Now notice that in here we have the same base. Here we have the same base. Make sure that you understand this only works when you have the same base. Our next property is called the powers of a power property. To find a power of a power, you multiply the exponents. So for example, in numbers, this would look like 4 to the 6th to the 3rd would equal 4 to the 6 times 3, which would give us 4 to the 18th power. Now, if we wrote that as algebraically or in algebra terms, that would show you that a to the m to the n would equal a to the mn, because you can multiply m times n, which will give you mn. Now, if you're taking the power of a product, which basically means you're doing this and this, you're using both of these together, to find the power of a product, find the power of each factor, and then multiply. So for example, in math terms, you could write 3 times 2 to the 5th power. Now you're going to think to yourself, well, I can take 3 times 2 and get 6 and 6 to the 5th power. Yes, you can. But what happens when one of those numbers is no longer a number, but a variable? And you'll get to that in some examples. So you can take 3 to the 5th power times 2 to the 5th power. In algebraic terms, it would look like this. AB to the m power would give you a to the m power and b to the m power. You take everything in the parentheses to that power. All right, let's start with some examples. Example 1a, we're going to simplify. 2 to the 4th power times 2 to the 5th power. That would give me 2 to the 9th power. Notice we have the same base. We add the powers. A big misconception is people are going to take 2 times 2 and get 4. That's not what you do. These are the base remains the same. Now you could take 2 to the 9th power and actually take 2 times itself 9 times and get an actual value as well. B. Let's do 3 to the 2nd power to the 3rd power. In this case, we're going to multiply the two powers, which is 2 times 3. That will give us 3 to the 6th power. All right, the next example. X to the 3rd times x to the 7th. X to the 3rd times x to the 7th will give you what? It'd be x to the 10th. We add the powers because you have the same base. D. X to the 3rd to the 7th. We now have a power to a power, which means you multiply. So it would be x to the 21st power. E. Negative 5 times, and then in parentheses, negative 5 to the 6th power. Do you have the same base? Yes, we do have a base of negative 5. If there's no power written, though, remember there's always a 1 there. So in this case, you'd have negative 5 to the 7th power. And notice I have parentheses around that negative 5. It's important that you have the parentheses there. All right, example 2, you're still going to simplify. So we're going to do 2x to the 4th times 3x to the 2nd. When you have multiple terms, like notice now you have coefficients of 2 and 3. These are just basic whole numbers. Now I'm going to show you the long way to do this, what this means. This really means 2 times x times x times x times x. That's 2x to the 4th power. Times 3 times x times x. You could then multiply the 2 and the 3 together and get 6. And then how many x's do you have there? You have 6. So this would become x to the 6th. So you would have 6x to the 6th power. Now to get there, all you do is take 2 times 3, put 6. You have the same base of an x. Therefore, 4 plus 2 is 6. B. 2xy to the 3rd times negative 3 x y to the 5th. The first thing we're going to do is you multiply every number that's the coefficient. So we can take 2 times 3, that gives us negative 6. But then you multiply your x's, the same base. What's x times x? You should notice that there are 1's here. So that would give you x squared. We add the powers. Y to the 3rd times y to the 3rd will give you y to the 8th. So my answer would be negative 6 x squared y to the 8th power. Example C. 2x to the 3rd power. Big mistake. This is a huge mistake. You do not take 2 times 3. This means that you are taking 2 to the third power and x to the third power. 2 to the third power is 8, and then x to the third power just stays there. So you take 2 to the power of 3, which is 2 times 2 times 2, 8, and then you get x to the third. D, 3 x to the fifth y squared. We start off by taking 3 to the second power. 3 to the second power is 9. Then we take powers to powers. So we take 5 times 2, which is 10, and 1 times 2, which is 2. So my answer would be 9x to the 10th, y to the second. Let's make them harder. Let's do negative 2 x y to the fourth times 5 x to the second y to the second. Step 1, you always get rid of exponents first. So we're going to do this because it's to the fourth power, and we're going to do that to the second power. We do each of these terms to the fourth power. If you take a negative, and this may be something you know is a shortcut, it might not be. If you take a negative to an even power, a power of 2, 4, 6, 8, any even power, your answer is going to become positive. If you take a negative to an odd power, your answer will always be negative. So in this case, we take negative 2 to the fourth power. Well, that gives me 16. Then I multiply my powers, power to power. So this will give me x to the fourth, because 1 times 4 is 4. We also take 1 times 4 again, so that would give me 16x to the fourth, y to the fourth, times. I now take 5 squared, which is 25, 2 times 2, which is 4, and 1 times 2, which is 2. You now are doing the product, you're doing the rule, where you're going to take the same base, multiply it by itself, you're doing the product of a power. So you're going to multiply your bases together and add the powers. So we're going to start with 16 times 25. 16 times 25 gives you 400. X to the fourth times x to the fourth gives you x to the eighth, since we add them. And y to the fourth times y to the second gives me y to the sixth. So my answer would be 400 x to the eighth, y to the sixth. Why don't you try b together, or by yourself? I'll put b down, pause the video, and then try it yourself. So there it is, 3y to the second times negative 4xy to the third, all to the third. Pause the video. If you did it correctly, you should get negative 192 x cubed y to the 11th. We start off by looking here, and we don't do anything with the 3y to the second, it comes down. We then take negative 4 to the third power, which is negative 64, 1 times 3, which is 3, and 3 times 3, which is 9. We then multiply negative 64 by 3, that gives me negative 192. X to the third, well, there's no x value over here, so that just comes down as x to the third. And then we add the y powers, which gives you y squared times y ninth. That gives you y to the 11th. We add the powers together. Example number 4, and I do want you to write this down. On the left side, you're given some information about details of a computer storage space. Here's the problem. A gigabyte of computer storage is 2 to the 30th power bytes. The details of a computer are shown on the left. How many bytes of total storage space does the computer have? Well, the first thing we're looking at is the total space. The total space of the computer is 64 gigabytes. Each gigabyte is 2 to the 30th bytes. So how many total bytes are there in a computer if each gigabyte has 2 to the 30th bytes? Well, you'd take 64 times 2 to the 30th. Here is the biggest mistake students make. They take 64 times 2. You cannot do that. You absolutely cannot do that. Don't ever do that. That's like taking this. 3 times 2 to the 4th power. You don't take 3 times 2. You do exponents first. So you take 2 to the 4th power and get 16 and take 3 times 16 and go from there. But we're not doing that. In this problem, we have to convert 64 with a base of 2. Remember, we have to have the same base if we want to multiply them together. So, you're going to rewrite 64 as a base of 2. 2 to what power gives you 64? 2 to the power of what number gives you 64? If you take 2 to the power of 6, you get 64. Now we have the same base, which means we add the powers together. So, how many total bytes of storage does this have? We would have 2 to the 36, and we probably should label this bytes of storage space. And there's your answer.